The MAF sensor in this 99 Jeep Grand Cherokee is a very simple one. Basically, all it does is it reacts to the pressure in the intake manifold and varies voltage accordingly. Our specific Jeep varied voltage from 4.7 volts at 0 inches of mercury to 1.6 volts at 16 inches of mercury at an idle. Our circuitry is also very simple. Once again, a 5-volt supply going directly from the PCM, MAP signal wire going directly back to the PCM with its own dedicated ground. The PCM uses this voltage and it basically makes a decision about how to adjust air-fuel mixture during startup, during cranking, and what the engine load is at specific intervals, as well as throttle positions.
We're going to just show you what it sounds like operating normally. So now we're going to mimic if this vehicle had a chewed wiring harness or if the sensor completely failed. So we've unplugged the MAP sensor. Go ahead, fire it up. There are no codes present, so we're going to go ahead, fire it up, and we'll show you how it sounds and also data we get. So at first it's sounding pretty similar, but if we give it a bit of time, you'll hear it starts to sound different. Right now we're getting a code, but it's for an oxygen sensor, not the MAP sensor yet. And it took all that time for us to get that MAP sensor voltage too high. If we take a look at the data, we can see that it is showing that our MAP sensor is reading at about 5 volts, but somehow it's getting 13, 14-ish inches of mercury. And as you can see, this engine is not very happy with that sensor unplugged. Right now we're plugging back in the MAP sensor.
Yeah, we're reading right. Now we're at 1.4 volts.
So right now the MAP sensor is plugged in. We're sitting at about 500, 600, 700 RPM at idle, and I'm going to show you guys the different voltages and pressure changes as I give it throttle at various RPMs. So that's around 2,000, 3, 4.
So we've back probed the signal wire, and whenever we test it, we get 4.79 volts, 4.8, and then when we unplug it, we deadhead it and we get 5.22 volts. When we're testing on the ground wire, we get 26.8 millivolts to 30 millivolts, and then when we unplug it, we get 29 millivolts to 26 millivolts. So right now we are going to look at the inches of mercury for the barometric pressure. However, we flicker it to wide open throttle. And as you can see, it does not change. Now we're also going to look at the inches of mercury in vacuum whenever we also go to wide open throttle.
Right now is we have the MAP sensor connected to our own dedicated vacuum circuit. Joe will be reading off what the computer tells him versus what I'm actually making it in the MAP sensor, and the engine is going to run poorly when there is not enough vacuum, when it hits a sweet spot, and then it will also die when there's too much vacuum because of the air-fuel ratio.
Alright, key on engine off at 0.
Zero.
Firing her up. 0, 7, 8, 10, 12, 10, 15,
and the engine smooths out at about 15, which is where it's supposed to be. If you want to compare it to this, well, a little too low. Comparatively, 8K, we are mimicking the actual engine vacuum right now, so the engine is running really well. However, once we go past that, the engine dies.
So right now, we've set that fault using the Mightyvac so that the vehicle is tricked into thinking that it has a lower barometric pressure than it actually does. The MAP sensor is plugged back into the vehicle. We're sitting at 18.8. We're gonna see how it runs even though that MAP sensor is plugged back in. It should be reading 28.9, but obviously it's 18.8. Let's fire it up. So it immediately jumps back up. We tried this test before, and the vehicle died straight away. And honestly, it's not running too terribly at the moment. We're reading at about 23.6. So I'm gonna go ahead and cycle the key and see if it changes. After cycling the key, we got it to read 30.7 inches of mercury. If you just search MAP sensor here, you get some basic codes, right? One of the cool things is that it splits it down here for just this random P1296 code. You see typical things like your possible causes, your set conditions. However, under a different page, P1296, same code, it also gives you this diagnostic tree. But what's even more interesting is if you just search MAP sensor, you see other codes that have to deal with the MAP sensor. For example, fuel system too rich, in which it shows you the MAP sensor being defective or out of calibration could cause the fuel system to be too rich. Another one of those codes is that there could be a no response from the PCM with a no start condition. If you take a look, one of the things it asks you to do in the diagnostic tree is to disconnect the MAP sensor and to see if it starts. It also then, if that doesn't work at this point, gives you a verification test to take a look at.
We are shorting the 5-volt reference to the signal wire, and we're going to see what codes we get. So we're going to start up the vehicle and see what codes pop up. No codes are currently popping up, even though we're getting 5 volts to the signal wire. So now we are shorting the signal to the ground, and as you can see, the MAP sensor voltage is 0 volts. And we're going to start it up. And is staying at 0 volts. Let's see if it's brewing code. Code. We're getting no codes.
So right now we've got the mass airflow sensor unplugged here. I'm gonna try and get this vehicle to run just by blowing into the sensor, and then I'll show you guys the PID data from that. Go ahead, fire it up, Elias. So interestingly enough, after repeating that test a couple of times, obviously we still have the mass airflow sensor plugged in, but I figured it would have thrown a code. We are not getting a single code from doing that, even though we were getting it up to 72, 80, 90 grams per second worth of air.
To get the MAF out of the car, it is 2 screws, and upon inspection, we have a hot wire MAF. So we just unplugged the mass airflow sensor, and here are the 2 codes that we got. on the MAF sensor with the key on, engine off, back probed, we had on our VG wire, we had 2 volts. On our THA wire, or our air temperature wire, we had 0.72 volts. On our EFI relay, we had 12 volts. Whenever we made it an open, our MAF signal wire, we had 5.09 volts. Our air intake temperature had 0.06 volts, and our EFI relay still had 12 volts. Now we move to idling. Our yellow-black wire, which is our MAF wire, has 2.1 volt, and then our air temperature wire, which is our green wire, has 1.57 volts, and then our EFI relay has 13.9 volts, and it went up to 13 because the alternator is running.
So I'm going to do my best here to explain how a Wheatstone bridge operates. It all starts down here at the battery. We have the EFI relay right here. When the EFI relay sends power, it goes up through here into the start of our mass airflow sensor. So essentially, this transistor starts by blocking this resistance down here, and here we have our 2 different wires. When we have pulled down resistors down here, which help tell this transistor up here by sending voltage into it, how much voltage should be sent back down to heat up the wire. That information then gets relayed to our PCM, which is then able to adjust its systems based off of those readings.
As you can see right now, we have no codes present.
So I'm going to come around here, and I'm just going to unplug the mass airflow sensor. So the mass airflow sensor is unplugged.
Now we have a P0120, a MAF circuit low input fault, and an air intake temp fault. The air intake temp fault is because the IAT is located within the MAF, and the MAF is open, so we're going to have a fault there. So now we're going to try to start it up. And it's running fine. It's running fine at idle based off of, there's a tune that's already put into it that's pre-programmed in that allows it to run fine at idle.
So right now we have the MAF sensor plugged in, but we have the tube from the air cleaner to the throttle body unplugged. So we're gonna run the vehicle and see how it operates. And interestingly enough, throughout all of that, with it dying, we didn't get any trouble code.
Right now we are looking at the picoscope on key on, engine off, and we're gonna start the car. And it looks the exact same.
So we've got that reestablished. Right now, key on, engine off. We're gonna fire up the engine. And interestingly enough, we're still not seeing very much of a spike. So we're key on, engine off. We found out that the issue was we were using the wrong software. But now that we fixed that, we're gonna go ahead and fire up the vehicle. And as you could see, we got that spike there at the beginning. Elias is gonna rev it up a little bit. And you can see how we get those spikes now that we have it hooked up.